Alright, so this video is for the class Discovering Exponents and Polynomials, and in this video we're doing worksheet 1-5, and in this worksheet we're kind of breaking down some radicals. So these were the radicals you were supposed to have memorized before coming into this class, and if you're having trouble with these radicals, I want you to go to the review video, okay? And if you're not in my class, and you want to be in my class and learn this particular skill, you can go to the description and click on the link, and it'll bring you to OutSchool where I teach this class live. All right, so the ones that I have circled are the ones I'm going to actually do. So pause, okay, oh, and I'm going to do 16 too. All right, so pause, grade it, okay, know that you should have these memorized, so this should be easy. But I'm just going to show you how to break down a few, okay? Remember that the base is the same as it's the answer to a radical. That's why we don't call the argument the answer, because it would be confusing in the opposite operation. It's the answer to the argument, all right? So the base is what would be the base in the exponent if we wrote it in exponential form, okay? So go ahead and grade your paper, and then I will break down a few of these. All right, so I hope you've paused and everything. Let's break down a couple. All right, so one way I can do this is make factor trees, okay, and figure it out. All right, so 64, I might be able to look at this and say, oh, I know that's 8 times 8, but let's say I didn't, and I go about it by saying, hey, it's even, so I know at least 2 goes into it. And 2 can go into that 32 times. Oh, look, I know this is 8 times 4. Okay, and I know this is 4 times 4, and this is 2 times 2. Okay, and then each of these are 2 times 2. So I've broken it down to a bunch of 2's. Actually, it's 2 times 2 times 2 times 2. Let me make sure I get this right. 2 times 32, 8 is 4 times 4, which is 4 2's. And then 4 breaks down to 2 more 2's. So I have 1, 2, 3, 4, 5, 6, 7. I'm missing 1. 2 goes into that 3, 32 times. This is 8 times 4. This is not 4 times 4. That's 4 plus 4. So this is actually 1 less 2. Okay, that's where my problem is. This tree should have tapered out quicker. I did adding instead of what I was supposed to. Okay, so I have all of these 2's. I know that because this is this perfect square that there are only 2 things that multiply together to make it. So let's start just grouping this stuff into 2 groups. Well, I can make 2 groups of 2's which each have 3 in them. Well, I only need one of these groups for the base. So 2 times 2 is 4, times 2 more is 8. All right, this one's a hard one. This is one you just have to have memorized. You have to know that 11 times 11 equals 121 because they're both primes. So the other one that does this is square root of 49. I'll see if you can guess what that is. But we do have a couple that there's just only one way of doing it. Same with square root of 9. Any that there's only one way, and that way is 2 prime numbers. So like number 6 is also 1. It is 13 times 13. I can't break it down like I can the 64. So I wanted to do a couple where I show you, you just gotta memorize them, use the tricks in that review video. But then one's like 12, I could break down. I could say, well, I know this is even, right? I know this is even. So 2, 9, 98. 2 times 98. Okay, 2 is prime. Let me break down this one. And if I break it down, it would be what? I can do 2 again. Let's just keep doing 2's. Just, you know, to do it the most bare bones minimum way. So if I do that, that would be 49. Well, there's only 2 things that go into 49, and that's 7 and 7. So I have 2 times 2 times 7 times 7. And I know two things that are the same have to multiply together to get to this. So I could put a 2 in each one, and I could put a 7. See how I have 2 of each? So I could put a 2 in each, and I could put a 7 in each. 2 times 7 equals 14. I only need one of these to be the base, so the answer is 14. All right, this one. I know that if I add the digits, it equals 9, so I know a 3 goes into it. And if I divide 3 into that, I can see it goes 2 with that 27 times, okay? All right, 3 is prime. I know that 27 breaks down to 3 and 9. And I know 9 breaks down to 3 times 3. So now I have 4 3's, but because this is a perfect square, only 2 things multiply. So I can group 2 of the 3's, these 2, and then group 2 more of the 3's, these 2. And if I do this math, I get 9 times 9, and I only need 1 for the answer. All right, 2, 2, 5. It ends in a 5, so I know 5 goes into it, and I'm going to say it's 5 times 45. 45 is 5 times 9, and 9 is 3 times 3. Again, I can group these. I can group one of my 5's in each one, so 5 here and 5 here, and I could group one of my 3's in each one. 3 here and 3 here. So 5 times 3 is 15. So it's 15 times 15. I only need 1 for the base. So there you go. So there's a trick of how to do these. Break these down if you don't have them memorized. As you can see, I tried to pick the hard ones to show you a cross sampling of what you'll get with these. But if you're still having problems, go back to that review video. Do the review exercise. Go back, watch the video. All right, so I want to review this. Remember, what's inside is the argument. It's what would be the answer of an exponent problem. We can't call it the answer because then we'd get all confused when we went to radicals, so we call it the argument. This is the base. It kind of got pushed down. When I scroll, sometimes this happens. Okay, the answer is the base. What it would be in an exponent problem is this 2 is the base. Okay, so it's here and then it's here. Okay. And this right here tells me the index. How many times do I multiply that number together? Don't call it the exponent because an exponent is treated differently, okay? This is the backwards of it. This is kind of the division of it. So I've got to look at it differently. Because what we're going to say is divide this up into only one of them is the answer. All right, I only want 1/3 of the process. And that would be the next worksheet where we start writing these in radical explanation form. So I hope that helped, and I hope to see you guys in class or in the next video.